In one, current will be, in the other, both are having same thing, lambda, let it be lambda. There are, I'm interested in these points, P1, P2, and P3. What about the magnetic field strength at these particular points? So this is sheet 1, sheet A and sheet B, no? You can call this sheet 1 and sheet 2. What is the field due to sheet 1? How it will be? You take. I'll show the show by colors. Due to 1, it should be like this. Only one arrow I'll show it. It'll be easy for you. Okay, this one. And next after this. Due to this, it should be in this direction. And what about here? B bar, it should be like this. This is right separately. This is due to, this is B1, this B1, this B2, this B2. This is individually due to each sheet. What should be the resultant field at point P1? At point P1. Both will get added up at point P1. You have to take superposition, like how we did for charges sheets. At P1, it should be BP1 should be equal to B1 plus B2. Both are in same direction. So mu naught lambda by 2, mu naught lambda by 2. So will be mu naught lambda. What about P2? P2 you have to take superposition. I just shown only nearby it. You assume that only sheet 1 is present. You'll get confused. So now what I do, I'll show here also. It will produce field. This and similarly, this will produce field here in this direction. Mu naught lambda, lambda is the current per unit width, no? Only lambda will come, that one. Not mu naught I, only it will be lambda. Okay, now at point P2, take superposition B1 and B2. So this will be B2. This will be B1. No? Now at point P2 should be, resultant will be how much? B1 minus B2. B1 is mu naught lambda by 2. Opposite direction will be 0. Similarly at point P3, B1, B2 minus B1. Very important, how to produce that uniform field in a certain specific region. Shall I take help of this? Only in that specific region, only that limited region. Like that, what happen? The current carrying sheets will help us to generate uniform magnetic field. Do remember? So rather than giving uniform magnetic field, they'll give sheet, nearby sheet. So the field due to that will be uniform. Till where? Till, so within this region only uniform field. What about field here? 0. Here field will be 0. If the two sheets, if they carry current in same direction, then field here will be 0, here it will be non-zero. Check that analysis. Sir, what about field here? I think you go back, what they are, large current carrying sheets, no? So this will extend till infinity on this side, infinity on this side, this one. Again, don't think, sir, what about field here? This will tend to infinity like this. On this side also, this will tend to infinity. Is it okay? So you may get any numericals related to this. You have to be very careful. I can bring some suspended charge particle or charge particle, I'll make it to oscillate. I'll bring one spring block charged, I'll make it to move, or any motion of charge particle I can discuss here. Or a current carrying wire, I'll keep it, or dipole current carrying loop, I'll keep it, nearby current carrying sheet. All the application numericals will be there. Like that, if there are 3 sheets are there, yes, due to all 3 sheets, you take the superposition. So now what is the important thing? This sheet to what pen, not only to produce field here, will produce here also. If 3 sheets are there, again, if there are 3 sheets are there, now let this be lambda 1. I'm giving the charge density in this way. Okay, these are the sheets are there, no? So what about the field at this point? Who will contribute? All 3 sheets. I'll give only directions. Later on, you will just take the. Okay, due to sheet 1, the field will be, and it will be in this direction. Black is due to sheet 1. No, come for this. Due to this, it should be like this everywhere. Sheet 3. And it should be, okay, due to red color 1, it should be in this direction. Okay, now you take the vector, sum of that, and get the resultant field. Okay, I'm just giving diagram. Later on, you do calculations. What is a B1? So this, let me write at least 1, B2, B3. So what is B1? Mu naught lambda 1 by 2. All of you getting the superposition principle? What we earlier learned, no, the same superposition is brought for n number of sheets. Let it be. You can take superposition. You should not think, sir, like how come the field by this will be obstructed by this? No, the superposition takes place here. Any reason for that? If a 2 wires are there, I1 and I2. So at this particular point, the field is only due to wire Y2. No, both the wires, no. The field at this point is only due to wire 1 or only due to wire 2, due to both. Same thing for sheets also, finish all. The idea is very simple. Okay. Okay, let's go for the next concept. Okay, this is about the plates one. So let's come back to Amperes circuit law. We'll wind up today this one total. Okay, read the question now.